In the previous lecture, we have already discussed the working of bitwise operators. Now in this lecture, let's learn some of the applications of bitwise operators. Let us take this scenario wherein there are two friends, Kavya and Zed, who are on a secret mission, and the mission is very critical and they need to communicate some information or some data via the internet. Now the data they are communicating via the internet must be secure, as in no one in between should be able to read their message because they are on a critical mission and the mission is secret. So the data that they are sharing via the internet should not be revealed to anyone else. So this is the problem that we would like to solve. In this case, Kavya has to transmit some secret numbers to Zed and no one else should be able to recognize this number. Only Kavya and Zed should know about these numbers and no one else should know about these numbers. So while passing it via the internet, we need to somehow encrypt this number. Now, encryption is a process that will convert the original message into a secret code. Let's say Kavya has the original number to be transmitted. Let's say the number is n. If she applies this encryption algorithm or this method, she will get a secret number, and this secret number is the number that she is going to transmit via the internet. Now at Zed's end, Zed is going to receive the secret number via the internet, and you will use something called as decryption method or decryption algorithm to get the original number n. So in this way, we are actually safeguarding our message so that no one can read the message even if it's received. Now to allow this encryption and decryption to happen at Kavya's as well as the Zed's end, they will be sharing one unique number that is called as a key. That is a key, and this key is only known by Kavya and Zed. Now whenever they would like to encrypt or decrypt, they will be encrypting the message using the key and Zed would be decrypting the message using the key. Let's say in our case the key we have chosen is 13, 1313, and only Zed knows about the key and Kavya knows about the key. And let's say Kavya would like to send the number 5 to Zed. What would be her secret code? Now let's see how can Kavya generate the secret code out of this number 5. So here we are going to use bitwise XOR operator. Okay, this one cap. So what will Kavya do is Kavya will do 5 bitwise XOR with the key that is 13. Okay, so if you can perform this, what happens? What is 5? 5 is 0 0 0 0 0 1 0 1 and 13 is 0 0 0 0 1 1 0 1. Now if you perform bitwise XOR on this, what is the output is 1 1 output is 0, 0 0 output is 0, 1 1 is 0. Whenever we have different bit, the output is 1. In all other cases, output is 0. So if you just look at this, is nothing but 8 in decimal. So the secret code here is 8. So she is actually going to transmit the number 8 via the internet. Now when Zed receives the number 8, he will perform the decryption. Now how does he perform the decryption? He again applies the same method. He will apply the XOR operator. He will do 8 is the secret number that he has received. Okay, and he will do XOR. XOR with what? XOR with his key that is 13. 8 XOR 13. So what is 8 in binary? It is 0 0 0 0 1 0 0 0. And what is 13? It is 0 0 0 0 1 1 0 1. And Z is going to apply the XOR operator here, and let's see what is the output. It is 0 and 1 1 because they are different. 0 0 0 0 1 1 1 1 0, and all these bits are 0 0 0 0 0. If you look at this, this is 0 0 0 0 1 0 1, which is nothing but 5 in decimal. Now Z could actually get the original number that Kavya was intending to send. This is how encryption and decryption can be done using the XOR operator. I hope you have understood this. Now let's try to demonstrate the same by writing a computer program. Now if you just look at this code, this is bitwise encryption. So encryption will happen at Kavya's end. Okay. Now what will Kavya do is encryption, the key, secret key that Kavya is having is 13. Now these keys will also be shared with Zed, who is the receiver of the message, and the number she is willing to transmit is this number called as NUM, which is taken as an input here. And now at line number 14, I need to write my code, right? Let's see what would be the code here. Now I need to generate my secret number, which is already declared here in line number 9. So my secret number would be, I'll have to create the XOR of my original number with the secret key. This will give me my secret number, and now here this secret number I'm just displaying it here. Okay, now let's go to the receiver's end that is at the Z's end. Okay, this is the code at the Z's end. Okay, this at the receiver end. So Z is going to receive the number, and that number is received and stored in the variable num received. So this is the number, let's say the Z has received. Okay, I'm scanning that number from the user right now, and the secret key is 13 here also. The same secret key is shared between Z and Kavya. So this is 13, and here also Kavya is just having the secret key 13. And now the Z should retrieve the original number. So original number, so line number 14 I'm trying to write this code. Original number should be equals to, so Z will perform the XOR of the number that he has received with the secret key, right? So we have already demonstrated it should work, and Z is now going to display the original number. So first of all, let's try to run the code at Kavya's end. So bitwise encryption, I'm just compiling this code. Okay, let's say I'd like to transmit the secret number, that is 348 is my secret number that I would like to transmit, 348. Now I get this secret number is 337. That means this is the number that is going to be transmitted to the Z via the internet, 337, right? Now let's go to the Z's end and let me try to compile this code, gcc bitwise decryption.c. So now Z has received the number 337, right? If he writes this number 337, now see, he could actually retrieve the original number, that is 348, which was the original number that Kavya was willing to transmit. So this is how encryption and decryption was possible by using the bitwise XOR operator. Now let's move on to our final example. That is, you're supposed to write a program to check if the number is even or odd. That program should be written using the bitwise operator. You should check if the number is even or not using the bitwise operator. Now let's try to see how number is represented in terms of bits, how even and odd numbers are represented in terms of bits. Let's look at this example. 2, decimal 2 is represented like this in binary. This is 8 and this is 36. All these are even numbers. These three are even numbers. And this is odd number 3, odd number 7 and odd number 37. These are odd numbers. If you just observe this pattern, you will see that all even numbers are always ending with 0. The least significant bit, this is called as least significant bit, LSB. Even number ends with 0 always, and odd number ends with the bit 1. So can we now take an advantage of this last bit? That means if we can actually derive or extract the least significant bit, our job is done, right? Least significant bit is 0, then we can conclude that the number is even. And if my least significant bit is 1, we can confirm that the number is odd by looking at these examples. Now, what is the way we can actually extract the least significant bit from a binary sequence of a number? We cannot extract this LSB directly, but we can actually use the bitwise AND operator to perform this action. If I do bitwise AND with 1, let's say what is 1 in binary? 1 is 0, 0, 0, 0, 0, 0, 0, 1. Now if I do bitwise AND here, what happens? What is the output? Bitwise AND. Now bitwise AND will make sure that because all these 7 bits are 0, so I'm guaranteed that in my output the first 7 bits would always be 0, right? And the last bit would be either 0 or 1. The last bit would be 0 or 1 based on what is the bit value here. If this bit value is 0, then this is also 0. Okay, that means this is as good as my decimal 0. If it is even number, because the last bit in even number is always 0, therefore my entire number would itself be 0. Okay, so if I do AND with, if I do 8 and 1, the output is 0. If I do 36 and 1, output is 0. So that means if I perform the bitwise AND with any even number, my output is decimal 0. Now let's try to do the same with the odd number 3. Let's try to perform bitwise AND of 3 and 1. So what is 1? 0, 0, 0, 0, 0, 0, 0, 1. Now if I am performing the bitwise AND, I am guaranteed that because these 7 bits are 0, so I am guaranteed that the output here is 0, because in AND gate, if any one of the input is 0, the output is 0. Okay, so there are 7 zeros in the output, and here the last bit would be 1 here because both the bits are 1. Okay, if both the inputs are 1, the output is 1 in the truth table of binary AND. So you get the output. This is nothing but this is decimal 1. So 3 and 1 is decimal 1. If I perform 7 and 1, it's decimal 1. Similarly, if it is 37 and 1, this is decimal 1. So we can use bitwise AND as shown here to check if the number is even or odd. Let's write a program and check this out. So I've already created this program called as bitwise even or odd, and I've taken the number n as an input from the user, and my answer I'll be storing in the variable answer. Now let's write our expression here at line number 17. Now how do I check if my number n is positive or negative? By using bitwise AND. So I'll perform n ampersand 1. Okay. So if the output of this is 1, what does it mean? If output is 1, then it is odd, and if the output is 0, then it is even. Okay. So now let's try to display the answer here, and let's see. Compile this code. Let's input the number 3 and the answer is 1, meaning that 1 indicates the number is odd. Let's try to give any other number. Let's say 56. This is even, so the answer is 0. 0 indicates the number is even. Don't get confused that truth value should be 1 and the false value should be 0 like we have done in the logical operator. This is bitwise operator. So in bitwise operator, we do not work in terms of true or false. We work in terms of 0 and 1, bit 0 and bit 1. Okay, and that's all. It works fine. I hope you have understood what is the application of bitwise operators. We have seen the application of bitwise operator, bitwise exclusive OR, XOR, and bitwise AND. That's all in this lecture. Stay tuned.